Hello, good evening, everyone. So today we are having solve the session with week five. Week seven. Okay, so please keep your pen and paper ready. We'll solve the questions based on the topics of week seven. Okay. So join the peer deck first. This is the password for it.
Excuse me, sir.
Yes.
Actually, like all the live sessions that you are taking, like where to find the link, like YouTube link, it has not been updated in the YouTube.
No, it is there.
Ma'am, these like this sessions, the January sessions, like I was trying to find it out, but I only got the May session, like that was of previous year. I'm not able to find the January's link.
Okay.
and also the
Uh,
WhatsApp and also the WhatsApp message that we are getting, the Google Meet link is there, but the
mhm.
YouTube link is not available. So how to find that?
So these links we are updating on your calendar. So
Okay,
are you getting it there?
in the Google calendar.
Yeah.
Okay,
From where
ma'am,
you
let me
join
check.
the Gmeet, there only we save this YouTube link, and also
Okay,
technical team post it to YouTube also, like on our
okay,
channel.
ma'am. Right. Okay. Let me check and see
Okay,
if it is there. Thank you, ma'am.
yeah. So okay, you guys joined this peer deck. Only 8 people has joined. So the password will be there on the screen. Whoever joins late, join it. Okay, and answer there only. So there is a first question regarding samples. Okay. So let x1 and x2 be two IID random variables with mean mu and variance sigma square. Given below are three different formulations of the sample mean. A is x1 plus x2 by 2. B is 0.1 x1 plus 0.9 x2 and C is equal to x2. And you have to select which option is correct for the variance. For this kind of questions, you have to first calculate the variance of A, B, and C. So, will you guys try it?
Yeah, ma'am.
Yeah. Check it which one is. Okay, do you need more time? Or should I exceed the time limit? Okay, so how did you proceed for this question? The solution here. So we have given that x1 and x2 are two IID random variables, right? Are independent and identically distributed random variables. And also given that its mean is mu and variance of x1 and variance of x2 also, right? Both are given as sigma square. Can I say that? If they are saying that random variable with mean nu and variance sigma square, and as both of them are identically distributed, I can say that, okay, expectation of x1 is mu and expectation of x2 is also mu. Fine. Then we are interested in finding the variance of A, variance of B, and variance of C, where they have given three different formulation for sample mean. What do you mean by sample mean, by the way? Yeah. Do you remember? We have discussed the sample mean kind of things. If x1 and x2 are two IIDs, then what do you mean by sample mean?
So when we have different sampling, average of all those sampling, that we call sample mean.
Yeah. So when you do this kind sample of average of x1 and x2, you will get this x1 plus x2 divided by 2. So this is standard definition of sample mean. But sometimes you can define it like weighted mean also, which is given by like your B, that is 0.1 x1 plus 0.9 x2, and C is given as x2. So they have defined it as like this C. Okay. So we are interested in calculating which variance is higher than among all this sequence of the variance of A, B, and C. So what should we do? First, we will calculate variance of A. So how will you try it?
One by two the square variance of x1 plus
Sorry?
one
Yeah. Variance of
x1 plus variance of x2 as it is independent. That is 1 by 2 the square variance of x1
yeah, 1 by 2 will common out, so it will become 1 by 2 square, and yes.
variance of x1.
So now, can we separate them over addition?
Yeah, we can.
Why
As
it
it
is
is
so?
independent.
Because your x1 and x2 are
Independent.
independent, right? X1 is variance of x2. So we should mention it as x1 and x2 are independent. Fine. Then, yeah, variance of x1, do we know that? Yeah. It's what? Variance of x1 is sigma square. Similarly, for variance of x2, sigma square. It was given, right? See? So This is nothing but 2 by 4 sigma square, that is equal to sigma square by 2. Okay, this is what? Variance of A. What about variance of B? Now let's calculate this. So variance of B is given as 0.1 x1 plus 0.9 x2. Now, how? It's a linear combination, right? With different scalars. So as x1 and x2 are independent, so we can separate it over addition. And this constant will come out with the by squaring out, right?
Yes, ma'am.
So this will be 0.1 square x1. Sorry, variance of x1, right? Plus this will be 0.9 square variance of x2. So square of 0.1 is nothing but 0.01, right? And variance of x1 is sigma square plus 0.9 square is 0.81. Variance of x2 sigma square. So this is nothing but 0.82 sigma square variance of B. And what about variance of C? It's nothing but variance of x2. That is equal to sigma square. So now we also know that variance of A is sigma square by 2. So what will be the sequence for variances of A, B, and C? This sigma square, this sigma square by 2, and this is 0.82 sigma square. Yeah? Anyone?
C greater than C is the highest.
Okay.
So
B,
uh,
then A.
first it will be B, then A, then C. B less than A, less than C.
Are you sure?
B is 0.5.
B is 0.8.
Yeah,
A is 0.5.
0.5.
So which one? And then you are saying variance of C. So 0.82 and 0.5, which one is bigger?
B is bigger actually.
It should be CBA in decreasing order.
Is it fine if I write like this?
Yes, ma'am.
Yes. Yes.
Yeah.
So similarly, you can write it in another format also. As someone said, CBA in decreasing format. That means variance of C greater than variance of B. One and same thing, right? Do you agree? Are these both of these equal?
Yes, ma'am.
Yeah,
Yes,
okay,
ma'am.
Yes.
fine. So both are the same. So in the given options, option 1 was similar to this, so we'll take this one. Fine. Okay. So any doubt for this particular one? Okay. So let's move to the next question. So why we were able to separate over addition without having any extra term? Reason behind that was our x1 and x2 were given as independent random variables. What if they were independent then? Then why can't we separate out variance of a x1 plus x2 as a variance of x1 plus variance of x2? Anyone? So if any two random variable x1 and x2, if they are dependent, then the covariance of x1 and x2 will not be equal to 0. So we have to calculate it, and the extra additional term will be there whenever we separate out variance of x1 plus x2. There will be one more term that we have to subtract, that is covariance of x1 and x2. But if x1 and x2 are two independent random variable, in that case, covariance of x1 and x2 is 0. So we do not take care. We do not write that term. We have learned these things here. Do you remember? Covariance kind of things.
Yes, ma'am. That 2 plus x1 and x2, that terms will become 0, no?
Yeah. Okay. So question number 2. A fair die is rolled 1000 times. Let x denotes the number of times 6 is obtained. Find a bound for the probability that x by 1000 differs from 1 by 6 by more than 0.2 using weak law of large number. Did you guys get the question? What it wants to ask? So there is a fair die that you have rolled 1000 times, and you have denoted x as a random variable, which is denoting number of times you got the 6. Okay. We are interested in finding the bound for the probability that x by 1000 differs from 1 by 6 by more than 0.2. So do you remember weak law of large number? Like first write the weak law of large number and think about that, what the terms are given here, and can you fit there, these terms? Okay, I'm increasing the time for this particular question. Is there any doubt regarding question itself? Okay. So, what will be our first step? What's the solution? We go.
So
Let's, yeah.
this
It
one
has,
we need to take the lower bound, right?
sorry. Oh,
Is it lower bound, right?
yeah, lower bound. Upper bound
Uh,
by weak law of large number, what do we get? Upper bound.
here at least. So
What
1
is
minus
weak law of large number? First, yeah.
first one is that probability of that x bar minus mu greater than sigma less than is equal to sigma square by n delta square.
Just a minute. So you spoke about the probability, right? Inequality.
Yeah.
So the thing is, if x1 to xn, let's say they are IID samples over following the distribution similar to x, where expectation of x is mu, variance is sigma square, and sample mean is given as like x1 to xn divided by n, and what? Yeah. So once your sample mean is like that, then what will be the expectation of x? Well, okay, that is not needed here as such. Then they says probability of modulus x bar minus mu greater than delta. Delta is some length of the interval, whatever you want. Okay, is strictly less or equal to sigma square by n delta square. So, in this particular question, what they are asking, this is what? This is a weak law of large number, which says that probability that the difference between x bar minus mu, x bar and mu is greater than delta is bounded by upper limit sigma square by n delta square. Okay. So, our question in this particular question is says that there is a fair die that you have rolled for 1000 times. Okay, and x is random variable which denotes number of times 6 is obtained. Number of times 6 is obtained. So if you are rolling a die for 1000 times, okay, then can you just say what is x denoting in terms of that? X is number of times 6 is obtained when you roll a die for 1000 times, right? Fair die. 1000 times. Fine. So, yeah. How did you proceed for this one? You replied there, right? In the clear die, there is an answer is recorded there. So fair die is rolled 1000 times and there is a random variable which is denoting number of times 6 is obtained. So how will you go to this weak law of large number through this information? And they are asking that probability, find the bound for the probability that x by 1000 differs from 1 by 6. Okay, so I'm writing difference of x by 1000 by more than 0.2. So yeah, greater than 0.2. Yes. So the bound for this particular thing is being asked, right? This is our question. Yeah, using weak
Yes.
law of large number. Now you know weak law of large number also, and this is the given information. So yes, how should we proceed? What is our x bar here? What is nu here? Delta. So once you know what is delta, sigma square, and n we know, right? Because we have n is what? Number of
Number of
1000.
Number of times.
yeah, 1000.
1000.
You are saying 1000 by just observing you have rolled a die for 1000 times, right? If I give you this much information that weak law of large number is given like this, just look out this information and just tell me what is the n denoting here. If
It is the number of time the trial is performed. That
or yes, or in another term, what we say, it's a sample
Number of
size,
random
right?
variable.
Number of random variables, yes. Okay, number of random variables or a sample size, fine. So here we have defined only one random variable x. Then how will you apply the weak law of large number? And what is your delta, what is mu and sigma square? So what are the quantities we needed to solve these questions? Sigma square, mu, n, and delta square, right? Yeah. Delta square or say just delta, no problem. So how did you solve this? If you know that you have rolled a die for 1000 and x is denoting number of times 6 is occurring. So what was your action for this? So once you write this inequality from words to this mathematical format, what do you observe here? This is fitting in that particular form, right?
this is
Yes,
this is uniform, right? I mean, in this case, just if in case we need anything extra,
Mhm.
this is uniform paired die, right?
Uniform, but what is uniform, right?
The
Probably.
probability is uniform.
Probability of what?
Probability of the
Given
distribution is uniform.
Okay. So may I ask you what is the distribution here?
So
uniform distribution.
distribution is 1 to 6, but we are interested in 6.
Sorry, please repeat.
So the distribution is 1 to 6, but we are interested in 6.
1 to 6, that means, okay, you are considering that rolling a die. You
Yeah.
are, okay, as it's a fair die, yeah. Once you roll a fair die, the distribution will be uniform distribution and it can take any value between 1, 2, 3, 4, 5, 6 uniformly. Yeah, correct. This distribution is unique, but x's number of times 6 is obtained. So still we are not getting that, right? Are you getting me? Like,
What I'm trying to say is, in case we want the sigma, we can get the sigma from this. That's what I was trying to.
okay. So let's find sigma from here. What is sigma here? Variance of this random variable, right?
Yes.
See, whenever you are saying this is your distribution, so you have to denote it by some random variable, right? Let's say y. Okay. Is it fine if I say it as a y? And it's a uniform distribution, discrete uniform distribution, right? So what is variance of y here?
B minus A the whole square divided by 12.
Sorry, please.
B minus A, that is the formula of B minus A the square, whole square divided by 12.
Divided by, oh, sorry. This is square. By 12. Okay.
Yeah.
Then, do you know your B and A here?
Yes, B is 6 and A is 1.
Okay. But is this the formula for this one uniform? The formula is for, I think, continuous uniform,
Continuous.
right?
For discrete is n square minus 1 by 12, I think.
What? N square?
N square minus 1 by 12. That is the
Okay.
Correct
formula
is
for
right.
variance.
Yeah.
Yes.
And what
Discrete.
is N there?
N
Uh,
is
n is b minus a plus 1.
Okay, then what is the variance? If I ask you directly, what's the variance there?
Wait, I have to
So you guys have solved this question, right? Then how did you calculate variance here? Like what sigma square you came up with?
Ma'am, I think it's Bernoulli.
Sorry?
Ma'am, I think it's Bernoulli distribution.
Which Bernoulli distribution? If your output is 1, 2, 3, 4, 5, 6, then how are you, like, why are you saying this is Bernoulli?
Ma'am, if we get 6, then it's true, otherwise it's false.
Yeah, correct. That is the way. Yeah. So we see in the question, we are interested in 6 only, right? We know that it's a fair die. So that will help somewhere to us. Okay. We have rolled a die for 1000 times. That means our n is equal to 1000. That means we need x1 to xn till x1000, right? That is sample size was given to you 1000 times. So, and x is number of times 6 is obtained. That means, can I write x as x1 plus x1000? Now you will say how? How can you write this one? So let me just define my xi's. I have not still defined my xi's. Okay. Just by observing the question that a fair die is rolled for 1000 times, I got the hint that okay, my sample size is 1000. That means I need 1000 random variables. So now I will define a random variable xi, which will give me 1 if, yeah, die is what? Landed on 6?
Yeah.
Yeah. Or you just say 6 appeared, okay? If 6 appears on rolling a die. And 0 otherwise. So just tell me that thing, one thing, that if xi's are such a random variable, then will they be independent? That means x1 will give you 1 or 0 if 6 appears, or otherwise 0. X2 will give 1 and 0, right? Similarly. So just tell me, are they independent? Because we can apply weak law of large number if and only if these conditions are satisfied. Otherwise, we can't. So, are they independent?
they are independent.
So, they are independent, definitely, because it's a fair die. You will roll for first time, and let's say it gave you 5. Then, when you roll second time, it's independent then what outcome you got for the first time, right? So now your xi's are what? X1 to x1000 are following some Bernoulli distribution, right? If they are following Bernoulli distribution, then we need to write some with some probability, right? What will be this P then?
Probability of getting the 6.
Yeah,
It is 1 by 6.
yeah. This P will be 1 by 6. Why it is? Because given die is fair, right? It was a fair die. Fine. So for every step, there is a reason. So probability is 1 by 6. Now, if I say, you know that it's a Bernoulli random variable with probability 1/6, can you just give me what's the expectation of x size?
1/6 only, P only, ma'am.
It is equal to P, right? If x is a Bernoulli random variable, its expectation is P, that is 1/6. What is variance of xi?
P into 1 minus P.
P into 1 minus P, that is what? 1/6 into 1 minus 1/6. So this is 5/6, okay? 5/36. Fine. This is your sigma square. This is nu is 1/6. Now left with the delta. What should be your delta here? So they asked you to find the probability that the difference between x by 1000 to 1/6 is greater than 0.2.
Yeah.
So can you guys find
Find-
what is your delta here?
0.2.
0.2. So now you set up your nu here. Fine. We got nu exactly 1/6, right? If I define xi as a Bernoulli random variable, like this, then my nu is this one, sigma square is this one, delta I know. But now question remains. So now with this information, you will say, okay, then we just directly put all these value, whatever, yeah, delta square by n delta, sorry, sigma square by n delta square, as you know, each and every value. But just confirm whether your x by 1000, is it equal to x bar here? Just check it that. Because then only you will, like, your weak law of large number is valid, right? Are you getting me? What I want to convey here, that this term should be your sample mean. Is it? So just think of, if your xi's are random, xi's are Bernoulli random variable, okay, and you are interested in counting the number of 6. So if I add all the x1 to x1000, what it will give me? Yeah. Anyone? If you are saying that your xi is a random variable which will give you 1 if 6 appears and 0 if otherwise, okay? So if I did one experiment, like 1000 times I rolled a die, then I summed up whatever the values this x1 to x100 gave, what it will indicate?
It is the total count of 6 occurred.
Yeah. This will give me the total number of 6s, right?
Yeah.
6, okay. Because whenever 6 was appeared, it will be 1, otherwise it will be 0, right? According to this definition. Fine. Then just check, one random variable was given to us. That was x. Number of times 6 is obtained, right? When you roll a fair die for 1000 times. So can I say this is nothing but x? Do you agree with that? That this is nothing but x. X was denoting what? Number of times 6 appeared. When a fair die was rolled 1000 times. Is it so? This was given, right?
Yes, ma'am.
So now my x is nothing but sum of the random variables. So just recall what was the definition for sample mean, like standard definition for sample mean.
Sample mean is the population mean.
Yeah, but mathematically, it's, yeah, sample mean was equal. Okay.
X1 x2 till n xn divided by n.
Divided by n. Okay. So for this particular question, if I want to calculate what is my x bar, that will be sum of all 1000 random variables. divided by 1000, right?
Yes.
But from this equation, let's say A, can I say that this is nothing but x by 1000? Right?
Okay.
So now I have 1000 random variables which are following some distribution with what probability 1 by 6. They are IID with mean mu is equal to 1 by 6 and variance is equal to what? 5 by 36, and x bar is nothing but x by 1000. Then by using, and I know that my delta is given to me as 0.2. Then by using weak law of large number, what can I write?
1000, maybe 1 by 6 into 1000, ma'am. 1 by,
Sorry, yeah,
that is x bar maybe 1 by 6 times 1000.
1 by 6 times 1000, right?
Yeah.
Just a minute. Is less or equal to what? Sigma square by n delta square, right?
Yeah.
So this is nothing but x bar is what? X by 1000. Nu is what? 1 by 6. And delta is 0.2. Is less or equal. Just put all these values. What is sigma square?
5 by
5
30.
by 5 by 36, right?
Yes,
Multiplied by what? N is 1000.
1000.
And what is delta square? That is 0.2 square.
Yes.
Okay, so it's just you have to just solve this inequality, like calculations, right?
Yes.
So what did you get?
5 by 1440.
Yeah. Okay. So this is what your upper bound is. Okay. So did you guys understand how we solve this question?
Ma'am, can you please repeat how did we find the sigma square?
Yeah. So they asked us to solve the question using weak law of large number, and we were interested to calculate this probability that x by 1000 minus 1 by 6 greater than 0.2. But we were not sure that whether this is our x bar, whether this is mu, this is delta, that was we were sure. Okay. So given data was given
Delta
information.
is given in question.
Yeah.
Ma'am, delta is given in question.
Yes.
Okay.
So they have given this much information in question, this boxed kind of things they have given there. But we were confirming that whether it's a sample mean or not, whether it's a nu or not, whether it's delta or not. Because for to apply this inequality, we need this information that our xi should be independent and identically distributed random variables whose mean is nu and variance is sigma square and sample mean is given like that. Then only we can use this inequality. Okay. So the given information was a fair die was rolled for 1000 times. And one more thing was that x is denoting number of times 6 is okay. So from this 1000 times, we decoded that their sample size is 1000. So I just created one random variable xi, which will give me 1 when 6 is appeared, 0 otherwise. So when we have two outcomes, then we say the random variable is nothing but the Bernoulli random variable, right? Once it's a Bernoulli random variable, we need probability as our parameter. So we know that fair die was rolled for 1000. That means if you roll a fair die, probability of getting 6 is 1 by 6. So probability is 1 by 6, and these 1000 random variables are independent. Okay. So now you know that your random variable is following Bernoulli distribution. So you know that how to calculate expectation and variance of the Bernoulli random variable. So we calculated by using the formula of Bernoulli random variable, mu and sigma square. Okay. Bernoulli random variable mean for the Bernoulli random variable is P, and variance is P into 1 minus P. So done with that. Then we have to clear that this x by 1000 is nothing but the sample mean. So they have given that if you define your random variable like this Bernoulli form, then if you add all x1 to x1000 random variables, then this will give you nothing but the total number of sixes you got in your experiment when you rolled a pair die for 1000 times. So just recall that this total number of sixes were given by the random variable x. So this x is nothing but the sum of your sum of your 1000 random variables. So if I want to calculate the sample mean for this one, then I will write sum of all random variable divided by total number of random variables. So when I written like that, I found that okay, x1 to x1000, addition of x1 to x1000 is nothing but the x, the random variable given to me. So sample mean for the given one was x by 1000. Now we summarize the things that are we have x1 to 1000 independent random variable which are following identical distribution like Bernoulli with probability 1 by 6. So we have mean 1 by 6, variance as 5 by 36, and our sample mean is 1 x by 1000. Delta was given to us 0.2. Then we applied weak law of large number and we calculated the bound for the probability that x by 1000 minus 1 by 6 is greater than 0.2, has upper bound as 5 by 1004. Okay? Any doubt?
Yes, ma'am, got it.
Ma'am, this formula is in two form, right? One is the upper bound form and one is the lower bound form. How to
Yes.
decide that which formula to use? I mean, how to come to that conclusion? That is it asking a upper bound or lower bound?
Okay. So just read the question for that and you will get to know what to use. We used here upper bound thing, right? That the difference between x by 1000 from 1 by 6, they asked it by more than 0.2. So in the question itself, it was asking probability that x by 1000 differs from 1 by 6 by more than 0.2. That means you want x bar minus mu greater than delta. Okay. Whenever you will be asked for x bar minus mu less or equal to delta, then you can use that lower bound formula. Okay.
Ma'am, answer is A, right?
Yes. No. Why at least it's a upper bound, no?
Okay.
Once it's
The
upper
answer
bound, why will you say it's at least 5 by 1440? Your upper
No,
bound is
at most 5 by 1440. No? Yeah.
yes. Once you got upper bound as 5 by 1440, that means that's your maximum limit. You can't exceed that, right? That's what we mean by upper bound, right? That probability that x by 1000 will differ from 1 by 6 more than 0.2 is at max 5 by 1440. So your answer will be C, option number C.
So, ma'am, actually, it means that x bar minus mu should be more than 0.2.
Yes.
That is what more, right?
Yeah. Okay.
Ma'am, then
Yeah.
when will be the at least?
When will be at least? Okay. So if the same question I ask you that what is the find the bound for the probability that x by 1000 differ from 1 by 6. Okay. Just let me write there.
So just on a high level, asking this, maybe you are taking her question. So in the formula, it is the sample mean minus the population mean and greater than delta. That is 0.2, right?
Yeah.
Okay.
This one you are talking, right?
What is the delta, ma'am? Actually, delta is what here? Like delta is the band, is it? I mean that the range.
See, okay. See, if this is a random, this is a real line. Okay. This is real line, okay. And you know what our target is? In last session, I discussed with this that why we are studying this sample mean and all this thing, because now the experiment will be like that. You don't know what your random variables distribution is, okay? So you want to calculate that. So let's say this is mean of what? This Bernoulli random variable. See, I will relate this with this question. So remember that. So you have 1000 random variables which are following Bernoulli distribution with mean 1 by 6, right? So your mean is 1 by 6 and mean is here, okay? And what was your X bar sample mean?
It's
Okay. Just tell me one thing. What do you mean by mean and sample mean here? If I say in this particular question, we know that your new value was 1 by 6 and sample mean is what? X by 1000. What do you mean? What is the difference between this new and this X bar?
X by 1000 means how many times you are getting 6 after trying, means 100 times you tried and how many times you are getting 6.
Okay.
So
Not
the thing is the x bar can be close to mu, but it may not be exactly mu because it will have some variation, some amount of variation in that.
yes.
That is delta, no ma'am. That is mu and X bar. There should be some difference. That is the delta difference. No, ma'am?
Yeah. There will be some difference between X bar and mu, and that will be
X bar is
delta. Yeah.
the mean of the sampling, right?
Yes, exactly. This was the answer to my question. X bar is mean of your samplings. And what is mu here? When you throw a die, let's say, okay, a fair die was rolled for 1000, right? 1000 times. When you throw a die with and you defined a random variable as Bernoulli format, that if you got 6, then it's 1, otherwise it's 0. So if my random variable is like that, and I'm throwing a die, in that case, for that particular random variable, let's say x1, my mean is 1 by 6. Okay. Do you know mean of the random variable? My x1 is a Bernoulli random variable, right?
Yes.
With with probability as 1 by 6. So this mu is representing mean of these random variable x1 for x1, x2, and so on till x1 whole. And x bar is what? Sample mean. That means when you're for this particular, the experiment was you have rolled 1000 dice and then you calculated the sample mean where your distributions x1 to x1000 were following Bernoulli distributions. Okay. So mu will be somewhere, let's say this is 1 by 6 and we are calculating the difference between, and we have also calculated x bar also, okay, that is nothing but x by 1000. Now we are interested that what is the difference between this sample mean and this actual mean of the random
Distribution mean.
variable x. No? Yeah.
In the lecture, sir has described it as distribution mean.
Distribution mean, yeah. We can say it in distribution mean because this x1, x2, xn all are following Bernoulli distribution. So say it as a distribution mean. Yeah, correct. So distribution mean should be 1 by 6. And one more thing you might remember that we have calculated expectation of x bar, which we were given as, what was it? Do you remember? expectation of x bar. That means mean of the sample is nothing but mu. It should be equal to, right? Oh, don't get confused here. So now we know the exact value of nu, but we don't know the exact value of sample mean. So there will be some error between this value x bar and this. Error means the difference between this x bar and this mu. So we denote it by x bar minus mu. Sometimes we are interested in calculating. See, whenever there are error kind of things, we always define a length that this much delta I am okay with. Okay. Have you you might come across this kind of things in mathematics, that the error between these two terms I can bear up to only this epsilon or delta. Okay. So sometimes we say it should be less than epsilon. What does it mean by that? When we say x bar minus mu is less than epsilon, let's take it as a delta only. When we say the x bar minus mu should be less than delta, that means the difference between these two must be at max delta. That means if mu is lying here, my x bar should lie within this range only, right? Because then only, if I say my x bar is here, then the difference between x bar and mu will be this one, right? And I am defining x bar to mu distance as a delta. Fine. So this is what, when we are required to get our x bar lying between this range only, in that time we will use this terminology that x bar minus mu should lie between, the difference should be less than delta. In that case, your probability of that the difference between x bar and mu is less than delta will change to what?
1 minus sigma square and delta square.
What about this inequality?
That is greater than or equal to.
Greater or equal to. In that case, what it is?
That is the lower bound.
Lower bound. That means if the same question, if I change it, in the question they have asked the difference between x by 1000 and 1 by 6 should be more than 0.2. If I say that difference should be less than 0.2, then what is the bound for that probability? Then we will calculate like this. Okay. But now you guys tell me in the question which area they were asking for the probability. We were calculating probability of.
So they are asking the area outside the shaded line. It is outside this bound.
Is it area?
No, it's length.
It's length.
So if mu is somewhere here, x bar here, that is x bar.
I mean to say that it is outside this range. That is because it is more than delta. Delta
0.2. Yeah. Yeah. It should lie somewhere here. So we were calculating the probability that distance between x bar and mu should be greater than 0.2. That means our x bar should lie on this red colored part of the line, right?
Yes.
Okay. So did it clear your doubt or still you have it?
That time we can use at least, right?
Where?
Whenever you want to less than delta, we have to calculate less than delta.
This one, yes.
Then we can say it should be at least 1 minus sigma square by n by delta square.
Yeah. Okay. And this was representing that your x bar is lying in this region. So let's say if mu is equal to 0 and this is 0.2, this is 0.2, then they were asking that only, that x bar minus mu should be away from each other by at least more than 0.2, right? That means if x bar will lie here, then the difference between x bar and mu will be less than 0.2, right? If I plot my x bar at here, then that will not work. Okay. So we were interested in our question to find out the probability that x bar will lie in this region, this red color region.
Got it, ma'am.
Okay. So let's
So
move to
that
the
inner region is that mu plus delta and mu minus delta. That range is when the x bar minus mu less than delta. That is the range, that time length.
that inner portion, right?
Yes, yes, yes.
Yeah, that I have denoted here in upper part. Yeah.
Yes, yes. Okay, okay.
Okay. So let's see the next question. Okay. So they have given 6 random variable x1 to x6, the IID samples whose distributions has mean 15 and variance 4. Suppose the sample variance is given by this particular format that you are very well known, right? This is nothing but xi minus x bar, the summation of xi minus x bar the whole square divided by n minus 1, where your x bar is standard mean average, right? Then find the expected value of s square. Okay, try it. Did you guys understand the question first? That is most important. If I ask, they have given mean of 15. So this is mean of what?
Population mean.
Sorry,
Population mean.
not population kind of thing we have not introduced yet. But yeah, that's a mean of your distribution that is followed by your random variables xi.
It's a value of mu.
It's a value of mu, but it would be a mean of something, right? So we say that your x1 to x6, these are your random variables. They are IID samples. That means they are independent and identically distributed, like some another random variable x, whose mean is 15 and whose variance is 4. So if I ask you what is the mean of x6, then
15.
yeah. Okay. Okay, so done. So yeah, how to start with this given information? Solve it, right? Am I audible?
Yes, ma'am.
Okay. So the easiest thing is they have asked us a very easy question, that is expectation of S square, right? And
Yes, ma'am.
S square is given to us. There is what where S square is given as x1 minus x bar the whole square, so on, x6 minus x bar whole square by 6, where it is also given that x1 to x6 are IID samples, right?
And divided by 5, ma'am.
Okay, sorry. Are IID samples. Okay. And also given that mean and distribution is also mean and variance. So is it fine if I write it as a mu and sigma square as 4? Yeah. So my question at that time was what this mu and what this sigma square is. This is mean and sigma square, mean and variance, but of what? So see, in this kind of questions, when you say your x1 to x6 are IID samples, they might be following the distribution similar to some random variable, let's say x, okay, whose mean and variance are this, okay. We will not say this as a for time being as population. We will just say it's actually population only, population mean and population variance only. But when you have to explain someone, then you can't just say it's a population, right? You have to explain like that. Your x's are following, are identically distributed as like x, whose mean and variance is given to us, okay? So this was empty. So let's come back to this question. Expectation of S square. So when it comes to expectation, it's very easy because the expectation splits over addition, right? It gets split. So expectation of S square is 1 by 5, we can common out, okay. So may I write it as a summation of xi minus x bar the whole square? Is it fine for you?
Yes, ma'am.
1 to 6. This is similar, right? I just reduce the length of the expression by just writing summation 1 to 6, x1 to x6, okay. So as it's summation only, I can have 1 by 5 as a common term. And what about inside? Yeah, summation I is equal to 1 to 6 xi minus x bar the whole square, right? Now it's a minus b square. Can you just treat this equation as a minus b square? Hello. Is it fine if I write it as a
Yes,
summation is there, and I'm just changing this expression xi minus x bar whole square. I'm just expanding it. Then what I will get? Xi square plus x bar square minus twice xi x bar. Yes, what? Is it fine?
Yes, ma'am, it's fine.
Okay. So now next step, what should we do? Now summation is there and individual terms are there. So I can again, summation is associate, so I can write it like that, right? Do you know what what I am going to next? It's a summation I is equal to 1 to 6 xi square plus
X bar square.
summation, yeah, minus summation I is equal to 1 to 6 twice xi x bar. Then next, yes, what will you do if you are there?
And by expectation of summation of I 1 to 6 x1 square
A split over expectation.
plus
Okay, just tell me one thing. If I have expression like this, then what about this summation
last
I is equal to 1 to 6 x bar square, right? There is one term, summation. Let me write here. Let's give it as equation number 1, okay? So I have there one term, I is equal to summation I is equal to 1 to 6 x bar square. So any idea for this? X bar will be a constant term, right? It's a sample mean,
yeah, that
isn't it?
yeah.
So can I, when there is any constant term, we just common it outside, right? And then we will be left with summation I is equal to 1 to 6. What will be here? 1 only, right?
Yes, ma'am.
Then
Equal to x square into a 6.
so it's a 1 plus 1 plus 1 6 times, right?
Yes, ma'am.
So this is 6 x bar square. And what about this expression summation I is equal to 1 to 6 twice xi x bar. So again twice x bar is constant here and I is equal to 1 to 6 xi. Yeah. What about this? Summation I is equal to 1 to 6 xi. What is the
x1 plus
definition of x bar?
Yeah, x1 plus x2 plus
xi divided by n.
6, right? N means 6. So may I write this as a summation of xi where I is equal to 1 to 6. This is nothing but 6 x bar. May I write like this?
Yes, ma'am.
Yes, of course. So this is nothing but 6 x bar. Twice x bar multiplied by 6 x bar, that is nothing but 12 x bar. Okay. So just x bar square. Fine. Any doubt?
Yes.
Okay. So just put all this value in equation number 1. What we will get is expectation of s square is what? 1 by 5. Expectation of summation xi square I is equal to 1 to 6 plus 6 x bar square minus 12 x bar square. So then 1 by 5 expectation of summation xi square 1 to 6 minus 12 x bar square. So now any simplification is possible further? No, right? So what we'll do now, this is nothing but summation xi square. That means x1 square plus x2 square plus xn square, right? Till x6 square. So can I write it as summation I is equal to 1 to 6 expectation of xi square. I am just entering this expectation inside minus expectation of 6 x bar square. Is it fine if I write like this? See,
Yes, ma'am.
It is nothing but expectation of summation I is equal to 1 to 6 what xi square. So if you expand it, this is nothing but the x1 square plus x2 square till x6 square. So I can just write it at summation I is equal to 1 to 6 expectation of xi square. Fine. Now expectation of xi square that we can calculate. What about expectation of 6 x bar square? Expectation of 6 x bar square.
6
6 common out. Expectation of x bar
X.
square.
Yes, ma'am.
So now expectation of x bar square, expectation of xi square. That is the question for us. Okay. So let's start with the expectation of xi square. Do you know anything that will help to calculate this expectation of xi square? So just remember what is the formula of variance of xi?
Variance of x plus expectation of xi.
Yeah, it is like this. Variance of xi is equal to expectation of xi square minus expectation of xi the whole square, right? And expectation
Yes, ma'am.
of xi we know.
Yeah.
Variance of xi also we know that it is given what? Variance of xi is given 4, right?
Sigma square.
4. And what is expectation of xi square? We don't know. Expectation of xi 15, right? That's 4 square. So that implies your expectation of xi square is what? 4 plus 225. That is 229. Okay? Is it fine? Is it getting too much complicated? See, we were finding expectation of xi square. This value we don't know, so I just used variance formula. By variance formula, we know that we have given expectation of xi is 15 and variance of xi is 4. Because mu is 15, sigma square is 4. That's what variance of this is what. And our xi's are IID samples. So I can use this mean and variance for them, right? So that's why I used 4 here and 15 here. Okay. So let's then what expectation of x bar square is there? How do you calculate expectation of x bar square? So again, x bar is also a random variable, right? x1 to xn divided by n, right? So what variance of x bar, if I ask you, what's the formula for that? The same, expectation of x bar square minus expectation of x bar the whole square. Are you getting it or?
Yes, ma'am.
Yes, ma'am.
So just put all this value. What is variance of x bar? Yeah, that's a question now. X bar is a sample mean, just given as x1 to xn, sum of x1 to xn divided by n. Then what is the expectation of x bar and what is the variance of x bar? That we have discussed in last session, if you recall it.
Yeah,
Expectation
first one is mu, second one is sigma square by n.
by n. Okay, what is n in this particular question?
6.
Yeah, 6. And expectation of x, okay, this one we just to calculate. Minus this is mu square. Okay. Okay. So this is 4 by 6. And which is equal to expectation of x bar square minus what is mu? 15 square, right? Okay. So yeah, just calculated expectation of x bar is equal to what? 225 plus this is 2 by 3. Right?
Yes.
So yeah. Okay, just hold on this position. We will put all this value in this, let's say, equation number 2. So our expectation of s square is what? So expectation of s square is what? 1 by 5 summation I is equal to 1 to 6. Expectation of xi square minus or plus what it was? Minus 6 times expectation of x bar square. Fine. Let's put all these values. Yeah, xi square expectation of xi square is what? $229 minus 6 times this one is 225 plus 2 by 3. Okay. So we just calculate it. One by 5, this is 229 common and this will be 6, right? 6 multiplied by 229 minus here what? 6 times 225 minus 6 times 2 by 3. Okay. So yeah. 229 minus 225 is what? 4. 4 minus 2 by 3. 4 minus 2 10 by 3. Yeah. Done? Mm, 4. Fine. Did anyone got this answer when you were solving it? Is it fine? This was calculation part, right?
Yes, ma'am.
Okay. So just recall it. What we were asked to.
16.
Yeah. Sorry.
Answer should be 16.
What will be 16?
Answer.
Why?
There is a 4, one more 4 there. 4 into 4. Yeah. Yeah.
Where?
6 into 2 to 9 minus 6 into 2 to 5.
Yeah.
4 into 6.
Minus
That was
6 into 2 by 3, no? So I just common out 6 from all this and I got 229 minus 225 minus 2 by 3. Okay?
E of s square is equal to sigma square by the proof.
E of s square is equal to sigma square.
Yeah, ma'am.
Okay.
And
What is sigma square here?
even
Yeah.
Okay, ma'am, I get it.
It's
Okay.
so 4 only. Okay. Okay. Fine. So it was just we have given the formulation for s square and being asked for the expectation of s square. So just kind of mathematical computation only. Nothing that much complicated. So we just used all the mathematical things here. The thing is, whenever it comes to find out expectation of square of a random variable, at that time we go through this variance formula. Whenever we know the variance of random variable and expectation of random variable, and we find out the expectation of square of the random variable. Okay, that was the only tricky thing here. rest of the part was easier. Okay, any doubt?
Ma'am, direct formula is there, no, ma'am? Expectation of S square equal to sigma square.
Expectation of S square is sigma square. Okay.
Can we
Then
yeah.
yes, you can apply, but just tell me one thing. Then what should be the S square there? For that purpose only we have put this question. So I will give you clarity for that thing after solving the next question. Okay. Or if you know, you can tell me now, like when to use directly. Or otherwise, just solve this next question. You will get one clarity that how to avoid that mistake when do we use directly that formula, because that is theorem, so that's valid. That is 101% valid, but where to use is most important thing. Okay, so just try this next question and tell me what is the expectation of S square in this particular question. So obviously, don't
Here
use direct formula here. Okay.
there was a n minus 1, ma'am, that is like a sample. Here the divided by n.
Yes, exactly. Whenever you have n random variable, n IID samples, and your sample variance is given like this, where it is nothing but the summation of xi minus x bar the whole square divided by n. At that time, you have to go manually. But whenever your sample mean is, sample variance is given by summation of xi minus x bar the whole square divided by n minus 1. At that time, you can directly use the formula that expectation of x square is variance of x. Why it is so? The reason you will get to know in, I guess, week 9 when we will study maximum likelihood test. Biased, unbiased, like things.
Okay.
Okay. So there is reason also why do we use direct formula in the question number 3, like previous question we can use the direct formula, but in question number 4 in this particular one you can't use. You have to go through manually only. That is biasedness of estimation that we will study in week 9 or week 10 around. So most of the things are similar here. So I think you will do this calculation fast.
Hello, ma'am.
Yes.
I joined this session late, where I found this slide and with your solution.
Okay. We will be shared this PDF files in your portal.
In Jan folder.
Yes, January 24th.
Jan 24.
Yeah.
Okay, ma'am.
The current one.
Okay, ma'am.
Okay, done this one.
Ma'am,
Yeah.
where you uploaded all the week notes, ma'am?
Week notes link, like which one?
Like in
You are not audible.
okay, ma'am. At the last, you can share the link.
Yeah, sure.
Okay.
Is this question done?
Yes, ma'am.
Okay, but only 3 of you only have answered, right? So like maximum of the portion is done, right? You have to just substitute the values as mean and variance are same, only denominator is changed there. Okay. Okay. So we are given this, right? Expectation of S square is being asked where your sample variance is given like this. It's divided by, sorry. Okay. So the only change is this denominator part that is given 6. So yes. So we'll do the same thing. Expectation of S square is summation of this will separate out xi minus x bar the whole square, and we'll find out like how to solve this summation x bar square and xi squares. Then the question arises at this part, right? Expectation of S square is 1 by 6, and expectation of xi square minus 6x bar square. So what will you get? S is 1 by 6. Okay, is it fine if I write directly? Because the same thing is there, right?
Yes, ma'am.
Summation of summation is equal to 1 to 6 xi square minus 6 times expectation of x bar square. So yeah, it was 225, right? 229. 1 by 6, this will be summation 1 to 6. Expectation of xi square, we got it as 229 minus 6 times expectation of x bar square is what? 225 plus plus or minus some 2 by 3, right? Plus 2 by 3.
2 by 3.
Okay. These all things will remain same. There is no change. So
Yeah.
yes, what?
Yeah. Same.
Okay. So it will be 6 multiplied by 229 minus 6 multiplied by 225 plus 2 by 3. So yeah, 6 common out, 6 by 6. Here it will be 229 minus 225 plus 2 by 3. So what? 4 plus 2 by 3? 14 by 3. Is it fine?
Yes, ma'am.
Oh, just a minute. It should be negative, right?
Yeah.
3.4 something.
So 10 by 3. 12 minus 2, 10 by 3. Okay. So this is what expectation of S square. So the difference is whenever your S square is given to you as summation I is equal to 1 to n xi minus x bar the whole square divided by n minus 1. At that time, your expectation of S square is what?
Sigma square.
Yeah, variance of x, or let's say sigma square. Okay, but whenever your s square is given as summation, we can't say the for rest of the part, what for any other variance you have to go with the manual calculation only. But whenever your sample variance is given in this format, at that time you can claim that your expectation of s square is sigma square. But remember, rest of the things, that xi's are IID and all these things. Okay, do not forget that. Okay, the theorem, when you apply any theorem, then all the conditions that is required for it, just take what are the necessary conditions. If they are satisfied only, then you can use what are the direct results. So you can use this formula. Why? Because this is the unbiased variance for the sample variance that we will learn in maximum likelihood sessions when we calculate the estimations for the parameters. Okay, so let's have a last question. Okay. So this one is last question for today. A random variable of size 100 is collected from a population P, where P is following uniform distribution 0 to 20. Find the upper bound on the probability that sample mean will be at least 2 away from the actual mean using the weak law of large number. Enter answer correct up to 3 decimal. Okay. So just tell me one thing, which type of random variable P is? Yes, anyone? Here P is random variable, right?
Yes, ma'am. Yeah, this is
Which
uniform.
type of random
P
variable?
is given, no, ma'am, uniform.
Yeah, it's given uniform, but when I say which kind, that means discrete or continuous.
Population.
Continuous, ma'am. Limit is uniform 0, comma 20, no?
Yeah.
Continuous.
So it's a continuous. Okay. So you can use that formulas that you were talking for that discrete one. Okay.
A square divided by 3 delta, something like that. 3 and delta square.
Sample size is given here.
And in this case, it is at least. That means we have to go for the lower bound.
At least 2 away. Just take it. Just confirm it once again with your own.
At least.
Just if you are confused, then draw it on a real line and check whether what it's
Okay,
asking
okay.
for.
So it is again the upper limit because it is the line away from like mu plus delta. I mean, it is after the area mu plus delta.
Okay, just check it. We will discuss it after some time since everyone is trying it. Okay. So yeah, what's your bound there?
Okay, it is directly asking now upper bound. The question itself says upper bound.
Okay.
So in
That's
that,
okay. Their written is upper bound. Just for time being, just suppose that they have given only they have not given that word upper. Did you feel that it's upper bound? So just start it. Let's start the discussion. Okay. So the sample size is 100. Okay. And they said it's collected from a population P where P is following some uniform distribution with 0 to 20, right? Find the bound and the probability that sample mean. What will be your sample mean here? So see, whenever they talk about sample mean, that means you just consider this x bar as what there might be some 100 of, because why I'm saying 100, because they have given the sample size as 100. So there might be some 100 random variables which are following the distribution similar to this P. So my sample mean will be x sum of all this random variable divided by 100, right? So they are asking probability that sample mean will be at least 2 away from the actual mean. What is actual mean? What is sample mean? Sample mean is this one, right? What is actual mean? That's sample, that's population mean, right? So what will be actual mean in this particular case? As P is a random, P is a random variable which is 0 to 20. Yeah. So how did you calculate 10? B minus A divided by
2.
2, right?
Yeah.
Okay. So that's nothing but 20 minus 0 by 2, that is 10. Okay. So this is mean, this, okay. So sample mean will be at least 2 away from the actual mean. That means the difference between x minus mu is at least 2 away. So at least 2, if I say, is it fine? Modulus of x bar minus mu, that is difference between x bar and mu, is at least 2. How do you write mathematically to this statement? X bar minus mu is at least 2. That means how
less
would
than
you
equal to
write modulus x bar minus mu is at least 2, right? If I write greater than 2, that means
at least
what does it? This is at least 2. Okay. When I say x bar minus mu less or equal to, that means at most 2.
Yes.
Okay. Or less than or equal to 2. So we want to calculate this probability that x bar minus mu is greater than 2. So once you get to know this, you know that how to apply your weak law of large number, right? So this is in the form x bar minus mu is greater than delta. So what's your weak law of large number says?
Equal to less than or equal to sigma square divided by n delta square.
So even though, see, if this statement is given to you, can you just find out whether you have to calculate upper bound or lower bound with this statement only, isn't it?
Yes.
So even though in the question it is given upper bound, but from this statement only you can predict that what do you want to go for. Greater than delta is less or equal to what? Sigma square by n delta square. So yeah. So what's our x bar that we don't know? Mu is what? We have calculated 10. Is greater than delta. Delta is given to us 2.
True.
What is sigma square?
B minus A to the whole
Sigma
square divided
square,
by
yeah. sigma square is variance of p, and it will be b minus a the whole square by 12, right?
Yes, ma'am.
Okay, b minus a square by 12, that is b minus a is 20, that means 400 by 12.
Yeah.
Right? Okay. So sigma square is 400 by 12. What is n here?
100.
100.
100, and delta is 4.
No.
4.
Yeah, sorry, 2 square. Yeah, so it is 4 only.
Yeah.
Okay,
One.
so 400 cancel, it is 1 by 12 only.
Yeah.
Okay, so probability that the difference between x bar and mu is greater than 2 is less or equal to. The upper bound is 1 by 2. Okay, understood?
Yes, ma'am.
Okay.
Hello, ma'am.
Yes.
In the expectation of uniform, a plus b by 2 use होता है. Why b minus a by 2?
Oh, okay. Fine. That will be the formula correction. Okay, yeah. This one, right?
Yeah, ma'am.
Yeah. Yes, thanks. Okay. Any doubt? So, okay, this was all about this week 7 Solvita session. If you guys have any doubt, then we can discuss it on the next session. Okay. Thank you for today.
Thank you.
Ma'am, before ending, you can share the link, ma'am. Can you?
Yeah, sure. Just a minute.
Okay.
Link for this YouTube link, right?
No. YouTube link, I got it. Slide link, ma'am. Where I find
Okay,
the
slides will be
PDF.
shared by tonight by support team. That I will not share. The support team will share.
Where I found, ma'am?
On your portal only, where you find your lectures. Where do you have your all lectures? There you have supplementary contents.
Okay.
In that zone you will find, yeah.
Okay,
yeah. You have lecture slides there, right?
Ma'am.
In lecture slides, there will be solve with the instructor sessions will, portion is there. There only you will find this things.
Okay, ma'am. Thank you, ma'am.
Okay. Yeah. Thank you, everyone.
Ma'am, please share the YouTube link as well.